So welcome back to part 3 of this lecture on chapter 14 on cost of capital. As promised, I was going to work through a couple of problems that will hopefully help you out in the homework. And this first one is based pretty much on problem 15 in the book, which is part of the homework. I basically took that problem and changed out all the numbers so you can use that as a guide. So if you need a minute to write this all down, pause and then come back to me. I'm just going to talk through this. So at the very top we have the bond information, 7,000 7.5% coupon bonds, 15 years to maturity, selling at 95% of par with a semi-annual coupon. We have 300,000 shares of common stock, selling at $57 per share with a beta of 0.95. We have a 9% market risk premium and a 5% risk-free rate. Lastly, 12,000 shares of preferred stock, selling at $90 per share. If it's not said otherwise, you can always assume that the par value of preferred stock is $100 per share, and it's paying a 7% dividend. And lastly, a 35% marginal tax rate. So at this point, you have two choices on how to attack this problem. You can either start by calculating the costs, or you can calculate the capital structure weights. And in this case, I decided to start by calculating out the individual costs, starting with the cost of the debt, or the cost of the bonds. So this is just a simple bond problem that you can plug into your calculator. The future value is the par value of $1,000. The present value is the par value times the discount of 95%. So the present value is $950. The coupon payment is the par value of $1,000 times 7.5%. Divided by 2 because it's a semi-annual coupon. The N it's 15 years, but it's semi-annual, so there's 30 total periods. So that would be, N is actually 30. And the I over Y is what you're solving for here. And I came up with an I over Y of 4.04. Keep in mind that you have to convert that back to an annual rate. So you multiply by 2 and you get 8.08%. Now the last thing you have to do to calculate the cost of debt is you have to take the tax effect. So in this case, you're going to multiply the 8.08 by 1 minus the tax rate, and that leaves you with a after-tax cost of debt of 5.25%. The next part is the cost of equity, and I wrote up the cost of equity formula there. The cost of equity is the risk-free rate plus the expected market return minus the risk-free rate, otherwise known as the market risk premium, times beta. In this case, you were just provided the market risk premium, so you don't have to do this step here. This has all been provided. So the risk-free rate is 5%. The market risk premium is 9. You just multiply that by the beta of 0.95, and you get 5 plus 8.55%, resulting in a cost of equity of 13.55%. And then lastly, we have to calculate the cost of preferred stock. So to do that, you take your dividend amount divided by PO, or P sub O, which is the market value of the preferred stock. So to get the dividend amount, you're going to take the percentage, which is 7%, right here. You're going to multiply it by the par value of 100. So the dividend is $7. And you have the market value of $90. So going back up here, you divide 7 by 90 to get the cost of preferred stock of 7.78. So now you have your 3 individual costs. The next step is to calculate your capital structure weights. So for this part, you will start out with bonds. There are 7,000 bonds with a par value of $1,000 each. You can multiply those by the discount, or you could just multiply 7,000 by the market rate, which was already provided, or the present value, to get your market value of bonds outstanding, which is $6.65 million. For For the common stock, you take the 300,000 shares times $57 per share, and you get 17.1 million. And then lastly, for the preferred stock, you have 12,000 shares times a market price of $90 per share to get $1,080,000. You add that all up, you get $24,830,000. And then to get your percentages, you just divide this number by the denominator down here, and you'll get these numbers: 26.78, 68.87, 4.35. They should add up to 1. If I've made any errors in any of my calculations and you catch those errors, I will do push-ups for you in class on Tuesday. I'll do 10 push-ups for every error that you find. And then lastly, you're going to take these percentages, you're going to multiply them by your individual costs here in this table down below to get the weighted cost for each portion of your capital structure. And so here are the capital structure weights, and you just multiply them by the cost, and that results in your weighted cost. So for bonds, I get a weighted cost of 1.41%, stock 9.33, and preferred stock 0.34. And then you add those all together and you get your weighted average cost of capital of 11.08. And one thing I just want to comment on is that companies generally want their cost of capital to be as low as possible. And you might just pause for a minute and think about why they would want to do that. So the main reason is that the lower your cost of capital, the more projects you'll be able to accept at lower risk. For instance, if your cost of capital, your weighted average cost of capital is 13%, and you have a project that pays 12.5%, you won't be able to accept it because it's below the cost of capital. But if you're able to lower your WACC down to 11.08, then you can accept it. And so there's different ways to lower cost of capital, but probably the most effective way is to always be adjusting your capital structure. So if bonds are less expensive, you can take on more bonds, or if stock is cheaper for whatever reason, then you may want to increase your portion of the balance sheet with stock. And so you're constantly trying to find a way to balance those three to get the optimal capital structure that will lower your weighted average cost of capital. So that's it for this problem. I'm going to do one more.